Okay, so really important is this idea, and it's the essential question of the class that you're taking right now, which is how can we represent three-dimensional objects on two-dimensional surfaces? And the simplest kind of three-dimensional object is a box. And boxes are special because they have just three sets of lines. Shapes like this. Oh, that's not good. I gotta switch this down. Hang on. Shapes like this only have three sets of lines. So these level 1 shapes are the most basic form of three-dimensional object conceivable, right? You got lines going up, you got lines going this way, and you got another set going back. Okay, only three sets of lines. Everybody who wants to draw the three-dimensional world should start out drawing boxes because there's nothing simpler in the world that you can draw. What we've done so far is we skipped ahead to already representing all three dimensions, right? Because the isometric drawings that we've been doing do represent all three dimensions in one drawing. And I start with that because it's more fun, but there are more elementary ways to represent all three dimensions, and we're going to go over one of those today. The simplest way to represent all three dimensions is to create multiple drawings. Okay, so you're not trying to create a sense of a three-dimensional object all in one drawing. You create a series of drawings that taken together will represent all three dimensions. And the sample one that I'm gonna draw for you is this thing. Very simple. It's the little house with the sloped roof. We're gonna call this rectangle the floor. So we're gonna imagine that it's on the ground like this. And the first type of drawing I'm going to do of it is called a plan drawing. And the plan is looking down on it. So the scale of this drawing is going to be 1 block equals an inch. I can estimate that this is 2 inches by 3 inches. So my plan is just going to be 2 blocks by 3 blocks. So it's going to look like this. Does that show up okay on your screens? Notice that from above we can also see a plane change, right? Plane change is right here. There's one plane here and there's another plane here. So I'm going to indicate the plane change like this. So this pattern is going to be one that you're going to turn to all the time. When you draw the plan view of an object, you start by thinking about its footprint, like how much space it occupies on the ground, and then you look down on it, you check for any plane changes, and you draw the plane change and you're done. This is called a plan of the object looking down. The other type of drawing that we do is side views or elevations. The first elevation, we're always just going to rotate the object once like this, because that's going to give us a drawing that lines up right underneath the plan view. See, it doesn't get any wider or narrower when we flip it like this, right? So we're going to put the floor here, and notice our plane change is going to be right under the plane change up here. I know this is 3 units tall. And like that. So that's the first elevation. The second elevation, I'm just going to rotate this thing clockwise one turn and draw it again, and it's 2 units wide, so now we're going to see it, the width, and here's our plane change, which lines up with here. I'm going to rotate it one more time, and here's this plane change carries over, and we go down, slope down like that, and there's only one more elevation to do, which is this one. It's also going to be 2 units wide and with a plane change down here. Now, it's often convenient to label these drawings. How are we going to keep these, keep track in our heads of which side we're looking at? And the simplest way to do that is with compass points. So I'm going to take my plan drawing and I'm going to label it with north, south, east, and west. For this purpose, I don't really care, where the North Pole is in relation to where I'm sitting right now. The convention is, however you drew the plan of the object, you just put north on top and south on the bottom, and then east on the right and west on the left. Okay? And so then, if this was the plan, right, in the first drawing, which side is this? Well, I'm not going to ask you the question because I'm making a video, so I'm going to just tell you. It's the south side, right? So this is south elevation. This is the east elevation. That's the north elevation. And that's the west elevation. This is dead easy stuff. It's very simple. What a lot of students have difficulty with, though, is the idea that for these drawings to be legible, they have to be in order. And this convention of putting the plan on top, carrying down, putting the first elevation right under it, has to line up. You can't just, a lot of kids just like draw it over here, and then they'll put the next one over here. That's not how you do it. This lines up with this, so you don't have to even measure the width or count a second time. And this ground plane is consistent for all of these, and notice that the height is consistent with all of these. And when you jump from one view to the next, your plane change carries over. See, this plane change carries over to here, this plane change carries over to here, and this plane change carries over to here. So this way of organizing the drawings is really important. So when you start doing this, I'm going to leave this sample up, and you're going to create your own plans and elevations according to this pattern. So I'm going to stop the video now.